In this video, we're going to talk about how to find a cross product. Now, to start with, we need to talk about how to find some determinants. And what I mean by this is some notation like this. Let's say we have a 2 by 2 matrix. And I'm using these lines over here that talks about determinant. What this really means is that you want to do some multiplication, that direction and that direction, and subtract the results. So this is going to be A times D minus B times C. Just as an example, if I had here 1, 2, 3, 4, this would be equal to 1 times 4 minus 2 times 3. That's negative 2. Alright, what about if we've got something larger? Say a 3 by 3. A, B, C, D, E, F, G, H, I. Well, the rule is you take A times the 2 by 2 left over if you get rid of the first row and first column. So that's going to be E, F, H, I minus B times what you get left over if you get rid of the first row, second column. So that's going to be D, F, G, I plus C times what you get left over if you get rid of the first row, third column. It is very, very important. Yes, there's a minus sign here. So it goes plus, minus, plus. All right, let's do an example. 1, 2, 4, 0, 3, 2, 1, 0, 6. I'm just making up numbers. So this is going to be 1 times 3, 2, 0, 6 minus 2 times 0, 2, 1, 6 plus 4 times 0, 3, 1, 0. And for each of these, you use the rule up here. So this is going to be 1 times 18 minus 2 times negative 2 plus 4 times negative 3. And if it's okay, I won't focus on what that actually equals. But I wanted to focus here on, okay, this is this operation called a determinant. This is how we do it for a 2 by 2. This is how we do it for a 3 by 3. Why do we care? Why are we going through all this pain and agony? Well, here's why. In the operation that we call a cross product, so if we are taking something like V cross W, or in terms of components, V1I plus V2J plus V3K cross W1I plus W2J plus W3K. We can find this by taking the following determinant. I, J, K. Yes, those are vectors up there. V1, V2, V3, W1, W2, W3. Example time. Let's take 2I plus 3K cross I plus J plus K. So what we want is on the top row, I, J, K. Now what we want are the components here, 2, 0, note we don't have any J's, 3, 1, 1, 1. So here we go. What do we get? We get I times 0, 3, 1, 1 minus j, don't forget that minus sign, times 2, 3, 1, 1 plus k times 2, 0, 1, 1. And figuring out each of these, we're going to have negative 3i. Let's see, what is this going to be? 2 minus 3 is negative 1 times a minus sign, so that's plus. So that's plus j. And then we're going to have plus 2k. Ta-da! We have taken a dot product. One check by the properties. Oh, we just took a cross product. Did I say dot product? We just took a cross product. There we go. I was thinking dot product because we can check the dot product of this vector with either one of these two should be 0. You can check to make sure it works. But this is a cross product. And that's the way we algebraically find cross products.